Hi, we are Group 9 and our topic for today is Predominantly Cognitive Theories by Edward Tolman. Our objectives. First is the summary of the theory, second is its application in classroom learning, the third is its application to SLP, and fourth is a short demonstration depicting the theory. Summary of the theory. Edward C. Tolman is an American psychologist who developed a system of psychology known as purposive or molar behaviorism, which attempts to explore the entire action of the total organism. He coined the term cognitive map, an internal representation of external environmental features or landmarks. The thesis will be behaviorism. Behaviorism tends to only get what is observable, while the antithesis will be the gestalt, in which it handles more on the unobservable mental behaviors or mental processes. So behaviorism, that's a thesis. So purposive behaviorism is more goal-oriented and relies on its environment. In gestalt psychology, it is molar behavior. The opposite of molar is molecular. An example for gestalt theory would be if I would give you a math equation which was 6 divided by 5 times 3 plus 5 minus 11. We would not look at it as piece by piece because we all know that there is what we call MDAS, which is multiply, divide, add, and subtract. And we have to use it to get the right answer. We have to look at the equation too as a whole, not just parts, so that we can get the correct answer. So its synthesis is Edward Tolman's work. So Tolman used behavioral methods to gain an understanding of mental processes of humans and other animals. He also draws on Gestalt principles to argue that animals learn the connections between stimuli without any explicit biologically significant event to make learning occur. What is learned? So in cognitive map, we have a broad picture of the environment. Lay of the land is more on similar to road knowledge, as we know the layout of the cognitive map, like the specific layout of it. In principles of least effort, it is the contentation that the task will always be done in a matter that requires the least amount of effort or work. He studied behavior in order to discover cognitive processes, confirmation versus reward. For Tolman, changing reinforcement meant change in expectations and thus performance. Switching from one reward to another changes expectations, which can favorably or adversely affect performance. He did test on this with two groups of rats, the first group having sunflower seeds and the second group having crackers. Later on, he would change the sunflowers with crackers and the crackers with sunflowers. What he got was a change in performance from the rats that, let's say, had the better food, which was, let's say, crackers. Vickers' trial and effort, it refers to the hesitating look observed in rats and humans. So at a choice point where the animal thinks about going one way or another, before it actually does go one way or another, it hesitates. So that's what it means. Learning versus performance. Learning then was different from performance. The organism knows or learns about the environment but acts or performs on it only when the need or reinforcements arise. Latent learning. So it is learning that is not readily apparent as it is not shown behaviorally until there is sufficient motivation. Edward Tolman's test, he had three groups of rats. The first group, every time they would find the exit, they would get a reward, which is the green one, the color green in the upper right chart. The second group was never given a reward, so they were just wandering around the maze. The third group was similar to the second group, but then in the 11th day, he decided to give them a reward, and that shocked him. On the 11th day, he saw a drastic drop, and it was even lower than the first group. And then he said that learning is not only conscious but also subconscious. It is because of these types of motivation or circumstances which allows us to use knowledge or learning. Application of the theory to classroom learning. So the teacher discusses and shows you the process of how to solve a problem. You've learned how to solve the problem, but you have not had the chance to demonstrate that you have learned how to solve it. And then when the test comes, you are able to solve the problem on your own. So the application of theory to SOP. So we have learned them in the classroom, but we have not had the chance to demonstrate what we have until we work on it with our patients or clients in the future or in them. So short demonstration depicting the theory.
Good morning, everyone. Welcome to Math 101.
Morning, ma'am.
Good morning, teacher. Our topic for today is PEMDAS. Who can recall PEMDAS from their senior high school? What does M mean?
Multiplication, ma'am.
Sige, thank you. Go. D mean? Division. Very good, Miss Buyan. What does A mean, Miss Laporte?
Addition, ma'am.
Okay, what does S mean?
Subtraction.
Okay. I will demonstrate to you how to do PEMDAS. You do multiplication first. So, 2 times 3, what's the answer?
6.
Divided by 6.
1.
1 plus what? 1 plus 10. 11. Very good, Miss Buyan. Next example. 3 times 9. 27. Divided by 5.
It's 1.4.
5 plus 4 plus 7.
12.4.
What?
Yes.
What?
12.4.
Like that?
12.4, ma'am.
Okay.
Yes.
Guys, ay kuan sa you review sa your lesson kay there's emergency in the school. Kera?
Yes, ma'am.
Okay. Okay, you answer this activity in 5 minutes.
Okay.
Are you done?
Yes.
Miss Lacorte, are you done?
Yes, ma'am.
Okay, show your answer.
Yes, 13.
Okay, 10 points for all of you.
Thank you for watching.